Okay, so one important thing to appreciate about amino acids, we said metabolism. We said mainly you use them for protein synthesis. That's probably, 70-80% of our dietary protein goes in that direction. There's maybe another 10% that goes into the synthesis of specialized products, among which are nucleotides. Okay, so that we'll probably start that on Monday. And other specialized nitrogen-containing molecules derived from amino acids, like the neurotransmitters, catecholamines, like molecules like heme, creatine, things like that, that contain small molecules that contain nitrogen, are typically derived from amino acids. The remaining 10 to 20% of the amino acids we get will be used for energy, because we cannot store excess amino acids. Unlike glucose or fatty acids, we cannot store excess amino acids. So we get the carbon skeletons or the keto acids. And again, the terminology here is very important. Carbon skeleton is synonymous to the keto acid derived from an amino acid. So either way, either one means the same thing. Okay, so this really just to kind of try to put it together for you in the big picture. And in the case of that 10-20% of amino acids that get degraded, you see them here listed. They are going to produce keto acids or carbon skeletons, and they're all of these different molecules: alpha-ketoglutarate, succinyl-CoA, fumarate, oxaloacetate, pyruvate. That's one group. And obviously, those can feed into the TCA cycle, be metabolized that way, these keto acids. So does pyruvate. The other option is you produce these molecules, acetyl-CoA and acetoacetate. And here's really the definition of what is ketogenic and what is glucogenic. Anything that gives you acetyl-CoA or acetoacetate directly, without going through pyruvate, is designated ketogenic. Okay? Anything that can give you pyruvate is designated glucogenic. Why is that? Because pyruvate can be converted to glucose. If you form acetyl-CoA, you cannot go back to pyruvate. This is something I've been saying the entire semester. So anything that produces acetyl-CoA cannot go back to pyruvate. Therefore, these are strictly ketogenic. Okay? But pyruvate can produce glucose. And if you remember gluconeogenesis, the first important step is by pyruvate carboxylase giving you oxaloacetate from pyruvate. What is in the TCA cycle? You see oxaloacetate there? So that makes these guys, alpha-ketoglutarate, succinyl-CoA, fumarate, and oxaloacetate, all glucogenic. So any amino acids that give you any of those four intermediates in the TCA cycle become glucogenic. Okay? Because they all end up at oxaloacetate. Oxaloacetate can go back to glucose. So that's really the concept, an important concept to understand. And we'll get back to it in a little bit. And this is, again, just to remind you, all amino acids, once you remove the nitrogen, either most likely through transamination, you will end up with the corresponding keto acid / carbon skeleton. So if this were alanine, the keto acid would be pyruvate. And that's something worth remembering. There's a few amino acids, pretty common amino acids, you want to know for sure, always associate, if you remove the amine, what keto acid you get. So alanine, you'll always get pyruvate from. If you like this channel, please subscribe. Thank you.